Pleasant morning to everyone. Let us start with a quote said by Dave Waters on machine learning. A baby learns to crawl, walk, and then run. We are in the crawling stage when it comes to applying machine learning. On behalf of the Department of Computer Science, Sri Ramakrishna College of Arts and Science for Women, I welcome the resource person, Dr. Dinesh Babu R., Managing Director, BrainSpeak EduTech Private Limited, Chennai, for being with us today to deliver machine learning using Python with real-time application. I also extend my welcome to our HOD ma'am, Dr. N. Tajinisha, PG and Research Coordinator, Dr. B.G. Rani, faculties and students. I welcome you, sir. Though we have a lot list of achievements about Sir, I share with you only a brief introduction about him. Dr. Dinesh Babu has 12 years of experience in the training profession to both Indian and overseas students. He has completed BTech in Sri Angalaman College of Engineering and Technology, Trichy, and MBA in ICFAI Business School, Hyderabad, and completed PhD in the field of data analytics in BITS Pilani. He has worked for Capgemini as senior data scientist and also for iGate Global Solution as consultant in analytics division. He is a certified business analysis professional and a national level winner as a best data scientist in a data science competition conducted by Latent View Analytics. We feel great to have you in today's session, sir. Over to you, sir.
Am I audible then? Able to see the
Yes,
screen?
sir. Yes, sir, you're audible, sir.
Uh, Good morning. Everyone. I'm really thankful for being
So
deliver
your
the.
voice is breaking, sir.
Uh, okay, ma'am. 1 minute.
Now it is okay, sir.
Yeah. Good morning, all. And I'm really thankful for giving the opportunity to deliver the machine learning using Python session. Okay, to computer science department. Okay, this session is we are going to discuss detailedly about what is machine learning and the applications of machine learning, why we use machine learning across various industries, and also will discuss the machine learning algorithms. Also, will discuss in detail. Okay. So, before discussing about the machine learning, okay, according to you, what is mean by machine learning? So, what do you mean by machine learning? Have you heard this term? Okay. Just casually, you can answer whatever you know. So, what is machine learning? Okay. So, machine learning is nothing but based on the human being instruction, machine learns accordingly to automate the process. That's why we go for machine learning. So based on the human being instruction, machine learn themselves and it helps to automate the process. That's why we go for machine learning. So in this machine learning, we are using the Python software. Okay, we are using Python software. We are using. Okay, so here when we go for machine learning is very much helpful for automating the process. Whatever the business process we are repeatedly doing, that we can automate that. That's why we go for machine learning. What machine learning can do, whatever human being repeatedly we are doing, that we can automate that. For example, speech recognition. Hope you know that, which is there in your mobile, Google Assistant. So Google Assistant is works based on the machine learning only. With the help of machine learning one algorithm only, the Google Assistant recognizes speech accordingly to react to that. So that is works completely because of machine learning only. So with the help of machine learning, we can automate the process.
Okay, for example, one simple example, see that in Windows 10, also there is a speech recognition is there. So we have the options called Cortana. So where if you are saying something, it gives the relevant action. Open my computer.
Sure thing. Opening my computer.
Okay, so these are all the example of machine learning. Okay, so the speech recognition, voice recognition, pattern recognition. Okay, these are all works completely because of machine learning algorithm. Okay, based on the human being instruction, machine recognize and understand accordingly it automate that. That's why we go for machine learning. Okay. With the help of machine learning, we can do the pattern recognition, voice recognition, speech recognition. All these things we can achieve through machine learning algorithm. So machine learning is applicable in various industries like finance, manufacturing, bioinformatics, web mining, retail, medicine, telecom. So almost all the industries we can go for machine learning. With the help of machine learning, we can automate that in finance industry for credit scoring, okay, and manufacturing sector for optimization of resource, bioinformatics in that alignment of genes, so chromosome. At the early stage itself, we can able to recognize the alignment of gene. Web mining, the search engine is works completely because of machine learning. And retail industry, market basket analysis, medicine, telecom. So almost all the industries we use machine learning is used across all the industries. We can able to use the machine learning is applicable in all the industries. So machine learning is divided into three different modules. There are machine learning is subdivided into three modules. The first one is supervised learning algorithm. Second is unsupervised learning algorithm. Third is reinforcement learning. These are all the three modules are there: supervised learning, unsupervised learning, reinforcement learning algorithm. The first one is supervised learning. Supervised means there is a dependent and independent variable. So when we have dependent and independent variable, we go for supervised learning. Okay, when we have the dependent and independent variable, we go for supervised learning. So dependent variable means output variable. When we have input and output variable in the analysis, we go for supervised learning. Whereas unsupervised means we don't have any dependent variable, where all the variables are independent of each other, where all the variables are independent. That is unsupervised. So when we go for unsupervised learning, where all the variables are independent of each other. Okay, when we go for unsupervised, where we have all the variables are independent of each other. There is no dependent variable. In that case, we go for unsupervised. Whereas the reinforcement learning means only we have the response stimulus method. Google searches works completely because of reinforcement. So these are all the three modules in the machine learning algorithm. The first one is supervised learning. So which I already said, supervised means there is a dependent and independent variable in your analysis. We go for supervised learning algorithm. That is input and output variable. Whenever we have input and output variable in the analysis, we go for supervised learning. In that, we have different algorithms like regression, classification, decision tree, random forest. These are all the algorithms come under supervised learning. So when we go for supervised, regression, classification, decision tree, random forest. These are all the algorithms come under supervised. So when we go for regression, regression is nothing but to find the cause effect relationship. When we are changing one variable, how much impact is there on the another variable? That is explained in the regression. Regression is used to find the causal effect relationship between independent variables on the dependent variable. Okay, because of changing CEO of the company, is there any impact on the stock price? Okay, because of COVID-19, is there any impact on the economy? Okay, regression is used to find the causal effect relationship. When we are changing one variable, how much impact is there on the another variable is called regression. Regression is used to find the causal effect relationship. Next, we can go for classification technique. Classification technique mainly helps to classify the records. High risk customer, low risk customer. Likewise, when we are going to classify the records, we go for classification technique. Okay, when we are going to the bank for applying the loan, so the bank decides whether we are eligible to get the loan or not. So if we are eligible, how much we are eligible? So these are all the things nowadays automated happen because of machine learning. So based on the applicant transactions and the collaterals, accordingly bank decide whether we are eligible or not. If we are eligible, how much we are eligible. So these things are achieved because of machine learning. Then decision tree. Decision tree is another algorithm which is mainly used to explain the things in a pictorial form. For the particular problem, we can arrive the n number of solution. Okay, for the particular problem, we can arrive n number of solution. Out of which is the best solution for that problem, we can find with the help of decision tree. So decision tree is one of the supervised machine learning algorithm which is mainly helpful for classifying the records. That's why we go for decision tree algorithm. So these are all the different applications of supervised learning, that is face recognition, character recognition, speech recognition. So these are all the examples of supervised learning. The next one is unsupervised. Before that, let me show you one small video clip how Google used machine learning to automate the process in the Google Assistant app. Let me show you one small video clip how they automated the process with the help of machine learning. They used speech recognition.
As I said earlier, our mission for our assistant is to help you get things done. It turns out a big part of getting things done is making a phone call. You may want to get an oil change schedule, maybe call a plumber in the middle of the week, or even schedule a haircut appointment. You know, we're working hard to help users through those moments. We want to connect users to businesses in a good way. Businesses actually rely a lot on this, but even in the US, 60% of small businesses don't have an online booking system set up. We think AI can help with this problem. So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule an appointment for you. Let's listen.
How can I help you? Hi, I'm calling for a haircut for a client. I'm looking for something on May 3rd. me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. You have anything between 10 a.m. and 12 p.m.? Depending on what service she would like, what service is she looking for? Just a one haircut for now. Okay, we have the 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I'll see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks, great. Have a great day. Bye.
That was a real call you just heard. The amazing thing is the assistant can actually understand the nuances of conversation. We've been working on this technology for many years. It's called Google Dupless. It brings together all our investments over the years in natural language understanding, deep learning, text-to-speech. By the way, when we are done, the assistant can give you a confirmation notification saying your appointment has been taken care of. Let me give you another example. Let's say you want to call a restaurant, but maybe it's a small restaurant which is not easily available to book online. The call actually goes a bit differently than expected. So take a listen.
Yeah, may I hear you?
Hi, I'd like to visit for Wednesday the 2nd.
For 7 people?
It's for 4 people.
4 people with
Next Wednesday at 6 p.m.
actually we need to go like after like 5 people or 4 people you can come.
How long is the wait usually to be seated?
When tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too easy. You can come okay.
Oh, I gotcha. Thanks.
Again, that was a real call. We have many of these examples where the calls quite don't go as expected, but the assistant understands the context, the nuance. It knew to ask for wait times in this case and handle the interaction gracefully. But we're still developing this technology, and we actually want to work hard to get this right, get the user experience and the expectation right for both businesses and users. But done correctly, it will save time for people and generate a lot of value for businesses. We really wanted to work in cases, say if you're a busy parent in the morning and your kid is sick and you want to call for a doctor's appointment. So we're going to work hard to get this right. There's a more straightforward case where we can roll this out sooner, where, for example, every single day we get a lot of queries into Google where people are wondering on the opening and closing hours of businesses. But it gets tricky during holidays and businesses get a lot of calls. So we as Google can make just that one phone call and then update the information for millions of users, and it will save a small business countless number of calls. So we're going to get moments like this right and make the experience better for users. This is going to be rolling out as an experiment in the coming weeks, and so stay tuned. A common theme across all this is we are working hard to give users back time.
Yes. So hope you understand that. So these type of automations are happen completely because of machine learning only. The speech recognition, voice recognition, pattern recognition. Okay. So these are all the things is achieved completely because of machine learning only. Okay. These are all the things achieved completely because of a supervised learning algorithm. Next, when we go for unsupervised learning, unsupervised means we don't have any dependent variable where all the variables are independent of each other. So when we go for unsupervised means where all the variables are independent, we go for unsupervised learning. Okay, when we have all the variables are independent of each other, then it is unsupervised learning. We don't have any dependent variable. Okay, all are independent of each other. Then we go for unsupervised. In that, we have the algorithms like clustering, association, image compression, probability distribution, dimension reduction. These are all the different algorithms come under unsupervised learning. So the first one is clustering. So clustering is a grouping technique which is mainly used to group the homogeneous characteristics. Clustering is a grouping technique. Okay, clustering is a grouping technique which is mainly used to group the homogeneous characteristics or similar characteristics of response. If we want to group, we go for clustering. Okay, clustering is a grouping technique which is mainly used to group the homogeneous characteristics of response, the similar characteristics. Okay, for example, you know the brand name called Horlicks. More than 45 years, they are successfully running their business. That is completely because of clustering. Okay, so because of clustering. So clustering is a grouping technique. We can group the similar characteristics of response. We go for clustering. So clustering is mainly helpful for market segmentation. Okay. So based on the different target audience, they are providing the different solution, different product. If it is children, that is junior Horlicks. Age-old woman, women's Horlicks. Pregnant ladies, mother's Horlicks. So different target audience, different product. That is clustering. So clustering is a grouping technique. So clustering is a grouping technique, which is mainly used to group the homogeneous characteristics of response. Okay. So there are many companies successfully running because of clustering. You know the brand name called LIC. LIC is successfully running because of clustering. Okay. So you know around 5 to 6 years back, which cab services you know in India? Which cab services, which brand do you know in India for especially the cab services? Have you heard the brand name called Fast Track? So in those days and all, Fast Track is a player, only player, and very few players in the market. Are they reached a maximum level in the business? No. They didn't reach maximum level. You know, just 3 to 4 years back, the brand name called Ola, Uber, and I'll just 3 to Ola Mini, Ola Micro. So, am I audible?
Yes, sir.
Yes, sir.
So that is because of clustering. So clustering is a grouping technique. So we can group the similar characteristics of response. So different target audience, different product. Okay, different service. Ola Auto, Ola Mini, Ola Micro, Ola Outstation, Ola Rental. Okay, so different target audience, different service are there. So that is completely because of clustering. So clustering is a grouping technique, which is mainly used to group the homogeneous characteristics of response. Okay, clustering is a grouping technique which is mainly used to group the homogeneous characteristics of response. We go for clustering. Okay. Then association rule, which is also the part of machine learning, which is an unsupervised learning algorithm. Association rule. Association rule is mainly helpful to build a recommendation system. So when we want to develop the recommendation system, we go for association rule. Okay. For example, the brand name called Amazon, Flipkart, and all. If you buy one product in Amazon, Amazon recommend you. Okay. If you buy one mobile phone, okay. If you buy one mobile phone, uh, it recommends you what is the next product you want to buy. Okay. So these type of recommendation systems are works completely because of machine learning association rule. If you buy one product in Flipkart, Flipkart suggests you what is the next product you or suggested product. If the customer who buy this product, what is the probability or what is the suggested product also they can buy, the combination of products they can buy. So these type of things are done with the help of association rule. So association rule is very much used in the various places, not only in the e-commerce application, even in the YouTube. If you watch one video in YouTube, YouTube recommends you what is the next video you want to watch. So the relevant information, the relevant videos are recommends completely because of association rule. Okay. So these are all the things achieved with the help of association rule. Okay. So if you are buying one product, what is the probability of buying the another product? Okay. If you buy one product, what is the probability of buying another product? So these type of recommendations are done with the help of association rule. The third module is reinforcement learning. So reinforcement means based on the human being instruction, the machine learn accordingly, it automate the process. That is reinforcement. Many algorithms like chess, robot, okay, if you move one coin in the chess system, move automatically the another coin. Okay, robots. Okay, many gaming applications are developed with the help of reinforcement learning. Okay. So these are all the three modules in the machine learning. When we go for machine learning, there are totally three modules, that is supervised learning, unsupervised learning, reinforcement learning algorithm. So machine learning is one of the module in data science process. So this is the entire data science process. Okay, data science is a process where we can convert the raw data into meaningful information for taking better decision in the competitive business. That's why we go for data science. So in that case, so first we get the raw data, then we will process the data, then clean it, then we go for EDA. EDA means exploratory data analysis. Then we can apply the machine learning. With the help of machine learning, we can visualize the result. Finally, we can make the decision. So this is a process. Okay, this is a process. So machine learning is one of the module in data science. Okay, these are all the different algorithms which is come under machine learning. Under supervised, we have set of algorithms. Under unsupervised, we have set of algorithms are there. Under supervised, we have regression, decision tree, random forest, KNN, K nearest neighbor, logistic regression, decision tree, support vector machine, naive Bayes. These are all the supervised learning. Whereas when we go for unsupervised, we have k-mean clustering, SVD, support vector, and PCA, principal component analysis, then a priori algorithm, market basket analysis, hidden Markov model. These are all the algorithms are there under unsupervised and supervised learning. Okay, these are all the different algorithms are there under supervised and unsupervised. Now, let me show you one small video clip about how machine learning is used in the Boston Dynamics. So, when we go for Boston Dynamics, so Boston Dynamics is famous for robotics design and engineering company. Okay. Boston Dynamics is famous for robotics design and engineering. So last year, what happened? The Boston Dynamics introduced the dog-like robot they introduced, and this dog-like robot they implemented in the construction industry, entertainment, and different industries they implemented. So through that, they automated the process. Boston Dynamics, they introduced a dog-like robot. Through that, with the help of machine learning, they automated the process. That is works completely because of machine learning only. So let me show you one small video clip. So these type of automation, so how the dog-like robot or with the help of machine learning instruction, it is detected another robot. So the another robots comes to detect the metal object. Through that, it open the door and allow the another robot to enter into the room. These type of automations are done with the help of machine learning instructions. Based on the instruction, the machine learns accordingly to automate the process. That is achieved with the help of machine learning. So when you want to go for machine learning profession, so we need skill sets like you need computer knowledge to do the programming and statistical knowledge to build the model. So these are all the skill set required to get into this profession. We can acquire this knowledge through this certification course or this through this type of webinar. Okay, where we can apply machine learning. So machine learning is applicable in which are all the industries. Okay. So machine learning is applicable almost all the industries. We don't have any restriction on particular industries or particular domain. We don't have any restriction. It is applicable to all the industries. That is, one of the prestigious award in this world is Oscar. Oscar is one of the prestigious award. So last year, what happened? The Oscar want to predict the best picture award. For that, the company name called Clarenbridge and Cognizant, they came forward and they used IMDb, their Rotten Tomatoes, IMDb, their ratings and reviews, Rotten Tomatoes, their ratings and reviews. Okay, they used IMDb ratings and reviews and Rotten Tomatoes, the ratings and reviews. With this, they predicted that Revenant is a movie is going to won the Oscar. So 1 month before itself, they predicted that Revenant is a movie is going to won the Oscar. The same movie won the Oscar. So imagine that the machine learning algorithms are very powerful in terms of accuracy and prediction. Okay. Machine learning algorithms are very powerful in terms of accuracy and prediction. Even the Google search engine is works completely because of machine learning only. If you search some information, the relevant informations are coming because of machine learning only. If you search some in thing, the relevant informations are coming, that is because of machine learning only. So Google search engine is working completely because of machine learning only. Amazon, Amazon is completely works because of machine learning. If you buy one product in the Amazon recommends you what is the next product you want to buy. So these type of recommendations or suggestions are comes because of machine learning. And in the business terms, they use cross-selling concept. They use the cross-selling concept. Okay. If you buy one product, Amazon recommends you what is the next product you want to buy. Okay. So this is completely because of machine learning. Okay. If you watch the video in YouTube, YouTube recommends you what is the next video you want to watch. So these type of recommendation, if you watch one video in YouTube, YouTube recommends you the next video you want to watch. These type of recommendations are coming completely because of machine learning only. Okay. Even in the Facebook, if you log in into your account, so if you log in into your account, whoever friends is there in your account, those posts only feeds into your account. Okay, that is because of machine learning. Okay, if you add one friend in the Facebook account, Facebook suggests you who are all the friends you can also add as a friend. Who are also friends you can add as a friend. These type of suggestions are coming because of machine learning only. Okay, so Facebook, okay, YouTube, Facebook, these are all the things achieved because of machine learning. Okay, many gaming applications are developed with the help of machine learning algorithm, like FIFA, EA Sports, Jenga, okay, and Battlefield, one of the famous game, Battlefield is one of the famous game. So these type of things are developed with the help of machine learning algorithm. Okay. And even the FICO score to measure the creditworthiness of the person, to measure the creditworthiness. How in India we have CIBIL score or credit score, we have CIBIL score. Likewise, in the US, there is a FICO score is there to measure the creditworthiness of the person. Based on that, the 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 bank decides to release a loan. So these type of automations are done with the help of machine learning only. Okay, machine learning is used across all the industries. Almost all the companies nowadays implementing machine learning to automate their process because we are generating so much data. So in that case, the normal statistical analysis or computer software will not help. So we need a powerful algorithm. That's why we go for machine learning. So one of the example, let me put up here. So the brand name called Zara. Zara is famous for apparel division. Zara is one of the largest distributor in this apparel industry in this world. More than 84 crores of garments they are manufacturing in every year. They are manufacturing more than 84 crores of garments. And more than 18,000 new designs they have in their inventory. If that is a case, it is not easy that to manage the things in a computerized or statistical way. It is very difficult. They have the large number of inventories. They have the more distribution centers. In that case, so it is very difficult to manage the inventory. So that's why they kept RFID tag. Each and every garment, they fix the RFID tag. If that is a case, they fix the RFID tag in each and every garment. So if the particular customer, they purchased the garment, they remove the RFID tag from the garment, which means the garment is sold out. If the garment is sold out, then immediately it is giving notification to the stock room. The stock room gets the notification. The stock room, if they are analyzed, so if the particular model or particular design is moving fast, then the stock room giving the notification to the inventory or production department. These design we need to manufacture or produce more. So this design we need to stop the production. So accordingly, they are managing the supply chain more effectively. Demand and supply, they are managing more effectively. That is achieved with the help of machine learning. Okay, let me give you one small video clip about how Zara maintaining their inventory with the help of analytics and machine learning. So with the help of machine learning, they are managing their inventories and effective way of managing the supply chain also. This is achieved completely because of machine learning. So machine learning is applicable in almost all the industries. So it is not restricted with any particular industry or particular domain. So it is applicable for all the industries. We can go for machine learning. Okay. So machine learning is applicable in all the industries. Okay. So for instance, it is applicable from government to biotechnology, almost all the industries. Government, biotechnology, utility, energy, manufacturing, telecom, internet, retail, insurance, finance, healthcare, pharmaceutical, travel, gaming, almost all the industries. Okay, it is applicable in all the industries. We can go for machine learning is widely used in all the industries. It is used in the retail sector for doing the market basket analysis, store segmentation, product mixing. Okay, that is a retail sector. Then we can also, machine learning is applicable in telecom also for doing the subscriber analysis, churn analysis, healthcare, clinical data analysis, okay, and even banking analytics, banking one, sports sector, okay, the selecting the right player for the right match is very important. Learning and education, okay, and manufacturing sector, energy, e-commerce, Okay, almost all the industries, government, law, entertainment, almost all the industries we can use machine learning is used in almost all the industries. Okay, machine learning is applicable in almost all the industries. So we don't have any restriction. Machine learning is not restricted with a very, it is not restricted with any particular industry or particular domain. It is applicable for all the industries we can use. It is not restricted with any particular industry. Okay. And also machine learning is applicable across various business domains also. Okay. That is CRM, customer relationship management. Nowadays, all the business functions also nowadays generating more and more data. Okay, all the business functions like CRM, customer relationship management, to find the best prospects, to find the finding the important prospect of the business, we can go for machine learning. And risk management, operation, infrastructure, supply chain, HR. So almost all the business functions also, almost all the business functions also nowadays acquire machine learning. So machine learning is very much helpful for all the business functions. Okay. And when we go for machine learning is helpful in not only the web application, also it is helpful for mobile app also. Okay, so machine learning is not only helpful for web application, it is very much helpful for mobile app like taxi app or movie app, fitness app, food app. Like different app wise also it is very much helpful. Not only a web application, it is very much helpful for app wise also it is very much helpful. Machine learning is very much helpful app wise also. For example, if you buy one, if you order the food in Zomato or Swiggy, based on your order, based on your purchase details, based on the purchase details, so Swiggy or Zomato, it recommends what is the next order you want to buy. It recommends that. Also, it gives offers. So those type of recommendations are done with the help of machine learning. Okay. So these are all the different ways machine learning is used. So machine learning is applicable in almost all the industries, all the business functions also nowadays. Nowadays it is very much helps. Okay. And even with the help of machine learning, the China controlled the coronavirus spread and death in China. So as you know that COVID-19 is one of the pandemic disease, that is coronavirus. Actually, it originates from China, Wuhan. Compared to developed countries like US, Russia, Italy, China controlled the coronavirus spread and depth through machine learning, through face recognition with the help of surveillance strategy. That is, the Chinese authority actually deployed more than 300 million high resolution surveillance camera across the street. Through surveillance camera, they detected the corona affected patient by keeping the symptoms and scanning the face, and the face is linked with the national ID. So that the Chinese authority tracked their face in public transport, hospital records. So based on the affected patient, they kept the area as consignment zone. Through that, they controlled the coronavirus spread and depth. Okay, that is because of they controlled with the help of machine learning only. Through machine learning only, they controlled the coronavirus spread and depth. The spread and depth is controlled with the help of machine learning. Okay, let me show you one small video clip how China controlled the spread and depth through machine learning with the help of face recognition. In the machine learning, there is a face recognition concept, that is Viola Jones algorithm. Through that, they controlled the spread and depth in China.
They were all taught by Chinese authorities who deployed drones equipped with high-resolution cameras and loudspeakers. It's one part of China's massive surveillance strategy to tackle the spread of the coronavirus, which has reached just about every region in the country. The virus has infected more than 80,000 in China, resulting in the deaths of more than 2,000 people in the country, far surpassing the death toll from SARS.
The difference between 2003 and 2020 is really enormous in terms of the government's reliance on the development of surveillance technology. Almost none of these tools were on offer at that time.
Sophie Richardson is the China director at Human Rights Watch. She says during this public health crisis, China is embarking on an unprecedented use of surveillance by using big data and its citizens. So what exactly is China's surveillance strategy? And can it work to battle the epidemic? There are an estimated more than 300 million surveillance cameras in China. Authorities are using them to monitor Chinese citizens.
Many of the surveillance cameras in use in China now are equipped with facial recognition capabilities, which gives the authorities the ability to track who specifically has gone to which precise location.
Combine that with data scraped from hospital records, police files, and public transportation history. All that is stored and linked to national ID cards, which gives the Chinese government granular information about all its citizens. In January, a man who tested positive for the coronavirus used public buses and subways to crisscross China's eastern city of Nanjing. The police posted his journey with specific dates and times on social media, with a warning that anyone who was in that area get tested for the virus. China's public health authorities have been candid about the use of big data during this public health crisis.
大数据它会告诉你，你周围这个人可能是又去了，我这次感染者。
They even developed a mobile phone app called Close Contact Detector. The app has a database of people who have tested positive or have symptoms. So as soon as you type in your name and national ID and log in, the app will tell you if you ever come into close contact with someone who tested positive, or if you're in the clear. So far, more than 200 million people have used the app.
These new and different uses of technology around the coronavirus may help resolve some public health concerns, but it's also another way for the government to gather large amounts of information about people really effectively without their consent, and in some cases without even their knowledge.
Chinese health officials say all this data is in the pursuit of the epidemic.
第一个，你更进一步的摸清底细；第二个，你也可以说，我们把这个对相关部门，尤其是我们基层部门提供这种。
In China, many people probably have not developed that kind of awareness to protect the privacy, protect the civil liberties.
Yang Zhaguan studies global health at the Council on Foreign Relations in the U.S. He says many in China want this type of monitoring because it's about life or death.
And when they were given the choices of protecting their health and protecting the civil liberties from
So with the help of machine learning, they automated the process by using machine learning. With the help of machine learning, they automated the process, and with the help of machine learning, they recognize the face, and accordingly, they automated that. Okay, these are all the things achieved with the help of machine learning. Even the complex decisions we can able to predict and find with the help of machine learning algorithm. So all these things, whatever we discussed so far, all these things we are going to implement with the help of the tool name called Python. So, you know anything about Python? Why Python is so popular nowadays? Why Python is used in various places? Any idea why Python is used? So why Python is so popular nowadays? What is the reason behind? Just casually you can tell me why Python is so popular nowadays. So it is easy to learn and code. Okay. Any other views? Why Python is so popular in nowadays in all the field? What is the reason behind? See, Python is more popular because compared to other programming language, why Python is so popular means because there are a lot of inbuilt libraries are there. Okay, there are number of inbuilt libraries. So we don't want to write hundreds or thousand lines codes like Java or .NET. The people who don't have any programming background also they can learn this software easily. It is easy to learn, easy to use also because number of inbuilt libraries are there. Inbuilt powerful libraries are there in the Python. And it is an open source. Anyone, anytime, anywhere they can download the software easily. And it is a versatile. It is support multiple operating system, multiple language it is support. And big data compatibility is also there. We can integrate large volume of data also we can integrate that. So that's why we go for Python. So Python is the official language of Google. It is a number one programming language. Compared to other programming language, Python is having overage in the market. That's why we go for Python is having more demand in the market. Career wise, if you look into that, so as per the NASCOM, next to US, India is having the huge demand for machine learning profession. Also, there are more projects as well as and demand for the job opportunities are there in Indian market. Okay, who can get into this profession? The people from computer background, BE, BTech, MCA, PGDM. Okay, they can directly get into this field easily. And compared to other industry, machine learning profession pay wise also very high. Pay wise also very high. Opportunity wise also very high in this profession. Almost all the top companies implemented machine learning, like IT companies, KPOs, bank, analytics, all the top companies they implemented machine learning. Not only in India, globally, like Walmart, Barclays, Citi, UBS, Hyundai, Genpact. Okay. So globally also they implemented. Machine learning is implemented not only in India, globally they implemented. Okay. So with the help of machine learning, we can automate the process. So where the Google used a completely machine learning for automating their process. Let me show you one small example how Google implemented a machine learning in their process.
Talk a lot today about machine learning and AI. We think there is an opportunity to accelerate computing by working on this with everyone else. And so we are trying to do that in two ways. First, we are opening up core components of our machine learning systems. Last year, we open sourced TensorFlow so that developers can embed machine learning and deep neural nets with a single API. In 2015, was the most forked project on GitHub, and it is the #1 machine learning project on the site. Last week, we open sourced a natural language parser, which is also built on top of TensorFlow. We are doing these things so that we can engage the external community and work on this together with everyone. Second, for developers and companies out there, we are also exposing our machine learning capabilities through our Google Cloud Platform. We already have a cloud machine learning platform underway, and you get access to computer vision, speech, language, and translation APIs. And we are working on bringing many more machine learning APIs so that you can get access to the same great capabilities we have inside Google. We believe this will be one of the biggest differentiators for the Google Cloud Platform over time. And by the way, when you use Google Cloud Platform, you not only get access to the great software we use internally, you get access to specialized hardware we build internally. And talking about that, for machine learning, the scale at which we need to do computing is incredible. And so we've started building specialized custom hardware. We call these tensor processing units, or TPUs. TPUs deliver an order of magnitude higher performance per watt than all commercially available GPUs and FPGAs. And when you use the Google Cloud Platform, you can take advantage of TPUs as well. TPUs are what powered AlphaGo, DeepMind's AlphaGo, in its game against Lei Sedol. Go is an ancient Chinese board game. There's a simple 19 by 19 grid, but it is one of the most complex games humans have ever designed. It has more possible board configurations, many more possible board configurations than there are atoms in the universe. Beating Go for computers was widely considered to be the grand challenge for AI, and most people thought it wouldn't happen for another decade or so. So we are really thrilled that AlphaGo was able to achieve this milestone recently. One thing worth calling out, in the second game, there was a move 37 by AlphaGo. It changed the course of the game and is now widely considered one of the most beautiful Go moves ever seen in tournament play. It was not just an intuitive move, but a very creative move. We normally don't associate computers with making creative choices. And so to us, this represents a significant achievement in AI. By the way, Lei Sedol has won every single game since he played against AlphaGo, and he has even replayed some of the moves he learned from AlphaGo in that game. As the state-of-the-art capabilities in machine learning and AI progress, we see them becoming very versatile, and we think it applies to a wide range of fields. I want to give you two examples. First, robotics. At Google, a bunch of 20%ers decided to help train robots to pick up objects. You can see behind me. This is not new. You usually do it by writing control system code. You program the robots with rules. But this time, they decided to use deep learning techniques. So you create a continuous feedback cycle so that the robots can learn hand-eye coordination by themselves using deep learning. As you can see, they keep doing it and they keep learning it over and over again. And over time, they get better. And they even learn natural and useful behaviors. So for example, the robot is nudging the stapler away to pick up that yellow object. We didn't write that rule. The robot learned it automatically using deep learning. So it's an amazing example of what machine learning can do. Another example in healthcare. Diabetic retinopathy is the fastest growing cause of blindness. It affects 4.2 million people in the US and many more worldwide. To detect it, you need to do a scan of the eye like you see behind me, and a highly trained doctor can detect it. If detected early, the treatments are effective. If detected late, it causes irreversible blindness. And it's very, very difficult to have highly trained doctors available in many parts of the world. So we set out to work with a small team of engineers and doctors, and again use deep learning and start training on eye scans. And over time, our computer vision systems have gotten really good at detecting diabetic retinopathy early. This is still early and there's a long road ahead, and we'll work with the medical community to get it in the hands of as many people as possible. But you can see the promise again of using machine learning. When I hear about advancements like these, I'm reminded that we live in an extraordinary period for computing. Whether climate change, healthcare, or education, the most important struggles already have thousands of brilliant and dedicated people working to make progress on issues that affect everyone. Now consider what the best climate change researchers, doctors, or educators can do with the power of machine learning assisting them. As you've seen today, I'm incredibly excited about the progress that we are making with machine learning and AI. We believe that the real test is whether humans can achieve a lot more with the support of AI assisting them. Things previously thought to be impossible may in fact be possible. We look forward to building this future together with all of you. Thank you for joining us at Google I/O.
So, coming to the career aspects, with respect to, hope you understand in the last video clip about how machine learning is helpful to automate the process in not only in the healthcare or not only in the robotics industry. It is applicable in all the industries nowadays. Machine learning is very much helpful in all the industries, all the business functions for automating the process. Okay, so we use machine learning because opportunity wise also very high, career wise also it is very good demand is there. That's why we go for machine learning. So how 15 years back we all moved from manual process to computerized process. Nowadays we are moving computerized process to automated process. So when you want to go for automation, definitely we need machine learning. So machine learning is very important. Machine learning is very important for automating the process. When you want to automate, we need machine learning. Okay. So that's the brief about the machine learning. So we'll discuss some of the algorithm by using machine learning. We'll discuss in detail now. So far we discussed what is machine learning, what are all the modules in the machine learning, that is supervised, unsupervised, and reinforcement, and the applications of machine learning, why we are using Python, and what is the career aspects of machine learning and all we discussed. So let me explain some of the algorithm which is there in the machine learning in detail with the help of Python. Okay. Okay. So under supervised learning, there is an algorithm name called regression. Linear regression is one of the supervised machine learning algorithm. Okay. In this, we will learn what is regression, what are all the different types of regression, how regression is helpful for prediction. We'll discuss in detail. Okay. So regression is one of the supervised machine learning algorithm. Regression is a dependence technique, which means there is a dependent and independent variable. Regression is a dependence technique, which means there is a dependent and independent variable in the analysis. We go for regression. Correlation is an interdependence technique, which means we don't have any dependent variable, where all the variables are independent of each other. That is interdependence technique. Whereas regression is a dependence technique, correlation is an interdependence technique. Okay, interdependence means we don't have any dependent variable, where all the variables are independent of each other. So when we go for regression, regression is a dependence technique, which means there is a dependent and independent variable. Whenever we have dependent and independent variable, we go for regression. Okay. In that, we have, when we go for linear regression, we have two types of variable. One is dependent variable, another is independent variable. These are all the two types of variables. The dependent variable is an output variable. Independent variable is an input variable. Okay, the dependent variable is an output variable. For example, crop production. Okay, crop production is a dependent variable. Okay, crop production is a dependent variable. Okay, so crop production is a dependent variable. So in that case, the crop produce more based on the independent variable, that is rainfall, fertilizer usage. Okay, these are all the independent variable. The independent variables are rainfall, fertilizer usage. These are all the independent variable. The dependent variable is crop production is a dependent variable. And the independent variables are rainfall, fertilizer usage, soil fertility. Okay, based on the rainfall, based on the soil fertility, based on the fertilizer usage, based on this only crop produce more. Crop produce more and more. Okay, that is regression. Regression is used to find the causal effect relationship. When we are changing one variable, how much impact is there on the another variable? So that is explained in the regression. Okay. In the regression, we have two types of variable. One is dependent variable, another is independent variable. The dependent variable is an output variable. Okay, the dependent variable is an output variable. And the independent variable is an input variable. Okay, the dependent variable is an output variable and the independent variable is an input variable. The dependent variable is an output variable. Okay, or call it as response variable. Independent variable is an input variable. So based on the input variable, how much impact is there on the dependent variable? Okay, that is explained in the regression. So when we go for regression, we use some of the terms. That is bivariant regression model. That is the bivariant regression model. That is y equal to beta naught plus beta 1 x1 plus e. So y is a dependent variable. X is a independent variable. Beta naught is a constant. Beta 1 is a respective independent variable coefficient. That is regression equation. Then here in this regression algorithm, there is a term name called R square, the coefficient of determination. The coefficient of determination is a deciding factor in regression. So based on the coefficient of determination only, we can get to know how much independent variable is going to affect the dependent variable. Okay. So how much input variable is affecting the output variable? So that is explained in the coefficient of determination. That is explained in the R square. The R square value is ranges between 0 to 1. Okay, the R square value is explained in 0 to 1. So based on the R square value only, we can come to know that how much independent variable is affecting the dependent variable. R square is a deciding factor. Based on the R square value only, we can come to know how much independent variable is affecting the dependent variable. R square is a deciding factor. Here, estimated or predicted value, that is beta naught and beta 1 are the estimated or predicted values. Then we go for regression coefficient. Beta 1, beta 2, beta 3 are the regression coefficient. Then we go for scatter diagram. So scatter diagram is used when both x and y axis, which means both dependent as well as independent variable. When both the variables are continuous, then only we go for scatter diagram. Scatter diagram is used when both dependent as well as independent variable, when both the variables are continuous, then only we go for scatter diagram. Then here we are using the standard error. Here there is a standard error is there. Standard error is nothing but standard deviation. Okay. Standard error is a standard deviation. Then here we are using t statistics. That is t-test we are using because the variables are continuous variable. So in this machine learning algorithm, there are two types of variable. One is categorical variable. Another one is continuous variable. The categorical variable means predefined. For example, gender, male, female, specialization in MBA, marketing, finance, HR, operation. Okay, these are all the categorical variable. So if the variable is predefined, we call it as categorical variable. If the variable is continuous, we can't predefine that. It can be any value. For example, sales. Sales can be any value. So if your dependent and independent variable is continuous, we go for t-test. So here we are using the t-statistics. If the variables are categorical variable, then we go for regression. So we go for z-test. Here the variables are continuous variable. That is the reason we are going for t-test. That is the reason we go for t-test. So in this regression algorithm, the deciding factor is R square. R square is the deciding factor. Based on the R square value only, we can come to know that how much independent variable is affecting the dependent variable. The R square value is ranges between 0 to 1. Based on the R square value only, we can come to know that how much independent variable is affecting the dependent variable. R square is a deciding factor. In the regression, R square is a deciding factor. Next, when we go for regression, in the linear regression is broadly divided into two types. One is simple regression, another is multiple regression. Okay, regression is classified into two types. One is simple regression, another is multiple regression. So simple regression means one dependent variable and one independent variable is a simple regression. Okay, one dependent and one independent variable. When we go for multiple regression, one dependent variable, more than one independent variable is a multiple regression. Okay, when we go for simple regression, one dependent and one independent is a simple regression. Multiple regression means one dependent, more than one independent is a multiple regression. So in this regression, we have linear and non-linear regression. Whereas in the multiple also we have linear and non-linear. Okay. So we have, when we go for regression, regression is broadly classified into simple and multiple regression. Simple regression means one dependent variable and one independent variable is a simple regression. Okay, let me give one example. So here, a real estate agent wishes to examine the relationship between the selling price of your home and its size. The size is measured in square feet. So here the dependent variable is house price and the independent variable is square feet. Okay, here the dependent variable is house price and the independent variable is square feet. Okay, the dependent variable is house price and the independent variable is square feet. So we need to find, because of square feet, is there any impact on the house price? So because of square feet, is there any impact on the house price? We need to find that. So when we go for linear regression, so in this linear regression, because of square feet, is there any impact on the house price? Okay, we need to find that. Okay, now this is the data. So there is a house price is mentioned and the square feet also mentioned here. So the square feet is mentioned, square feet as an independent variable. House price is a dependent variable. The house price is measured in $1,000. Okay, the house price is measured in $1,000. So house price is a dependent variable. Okay, house price is dependent variable and the square feet is independent variable. Okay, square feet is an independent variable, house price is a dependent variable. Now we need to find, because of square feet, is there any impact on house price? Do you think square feet affect the house price? So definitely it affects that, right? So if it is 1,000 square feet means there is some price. If it is 1,500 square feet means there is a different price, right? So definitely the square feet is going to affect the house price. The house price is mentioned in $1,000. Okay. Now we are going to discuss the detail about the regression. So when we go for regression, these are all the 5 steps we need to follow. The first step is we need to plot the scatter diagram, then formulate the general model. The third step, estimate the parameters. Fourth, determine the strength and significance of association. Fifth, significance test. These are all the 5 steps involved when we go for regression. When we go for regression, these are all the 5 steps. The first step is we need to plot the scatter diagram. Okay, we need to plot the scatter diagram. So as I already said, scatter diagram is used when both x and y axis, when both x and y axis were continuous, then only we go for scatter diagram. In that case, the dependent variable is plotted in the y-axis and independent variable is in the x-axis. When we go for scatter diagram, when we draw the scatter diagram, the dependent variable need to be in the y-axis. Dependent variable always we need to be plotted in the y-axis. And independent variable always we need to plot in the x-axis. So that is the first step. First we need to draw the scatter diagram. So with the help of scatter diagram only, we can come to know that whether regression is fall in the data set or not. Okay, with the help of scatter diagram only, we can get to know whether regression is fall in the data set or not. Here, the dependent variable is house price and independent variable is square feet. Here, the dependent variable is house price and independent variable is square feet. Okay, so we need to draw the diagram. So here we are getting the upward curve. We are getting the upward curve. So we can say that regression is fall in the data set. Okay, we can say the regression is fall in the okay, and we are getting the upward curve we are getting. So which means regression is fall in the data set. So which means regression is fall in the data set. Okay. So the first step is we need to say that regression is there. So first we need to say that regression is fall in the data set. First we need to draw the scatter diagram. First we need to plot the scatter diagram we need to plot. Second, we need to formulate the model. We need to formulate the general linear regression model. So this is the standard equation for regression. So this is the regression equation, y equal to beta naught plus beta 1 x1 plus e. This is a regression equation. Okay, y equal to beta naught plus beta 1 x1 plus e is a regression equation. So y is a dependent variable. X is an independent variable. E is a error. And beta naught is a constant. And beta 1 is respective independent variable coefficient. So this is an equation. Y equal to beta naught plus beta 1 x1 plus e. This is the regression equation. So here y equal to beta naught plus beta 1 x1 plus e is a regression equation. Okay, this is the regression equation. Y equal to beta naught plus beta 1 x1 plus e is a regression equation. Okay, this is the regression equation. Here, y is a dependent variable. X is an independent variable. Independent variable means input variable. Dependent variable means y. And beta naught is a constant. Beta 1 is respective independent variable coefficient. E is a error. Okay, this is the equation. This is the equation. Then if we plot the graph, this line is called regression line. The regression line which touches a y-axis, the below the value is called constant, that is beta 1. The slope of the line is beta 1. Beta naught is constant. Beta 1 is slope. So y is a dependent variable. X is an independent variable. E is the error. So y equal to beta naught plus beta 1 x plus e. This is the equation. This is the regression equation. Y equal to beta naught plus beta 1 x1 plus e. This is the regression equation. Y is a dependent variable. X is an independent variable. E is the error. Beta naught is a constant. Beta 1 is respective independent variable coefficient. Beta 1 is respective independent variable coefficient. This is the equation. Okay, the first step we need to verify whether regression is fall in the data set or not. So we are getting the upward curve. We drawn the square feet and house price. We found the regression is fall in the data set. The second thing, we need to formulate the model. That is a linear regression model. The third, estimate the parameters. How to calculate the beta naught and beta 1. That is the beta naught and beta 1, A and B, this value. So B is nothing but the slope. The slope we can compute by using this formula, B equal to covariance of xy divided by standard deviation of x. Covariance of xy by standard deviation of x is a b value. Okay, b equal to covariance of xy by standard deviation of x is a b value. The covariance is summation of xi minus x bar. Okay, so xi minus x bar into yi minus y bar is a covariance. Okay, 1 minute, 1 minute.
Girls, don't leave. I find three of them have left the meeting. Don't leave.
Yes. Yeah. So here when we go for the slope, so here we need to find the A and B value. We need to find the A and B value. So here we need to find the B is nothing but the slope. Slope we can compute by using the covariance of xy by standard deviation of x. The covariance we can compute by using this formula, that is summation of xi minus x bar into yi minus y bar is the covariance. Standard deviation of x is summation of xi minus x bar the whole square is standard deviation of x. Okay, this is the b value. So with the help of b value, we can compute the a also. So with this, we can frame the equation. So that is the estimating the parameters. So first we need to draw the scatter diagram, then model, then estimate the parameters. Then determine the strength and significance of association. Determine the strength and significance of association, that is R square. Determine the strength and the significance of association, that is R square. That is coefficient of determination. So the coefficient of determination is denoted as letter R square. The R square value is ranges between 0 to 1. Okay, the R square value is ranges between 0 to 1. Okay, so the R square value is ranges between 0 to 1. Okay, so here R square value is SSR divided by SST. Sum of square regression divided by total variation is the R square. So R square is SSR divided by SST is the R square. The R square value is ranges between 0 to 1 is the R square. So based on the R square value only, we can get to know how much independent variable is affecting the dependent variable. Okay, that is R square. Here, the R square value is explained variance divided by total variance is the R square. So here, the R square is explained variance by total variance is a R square. So the total variance is explained variance plus unexplained variance is the total variance. When we go for R square is a explained variance by total variance is a R square. Okay, here the total variation is explained variance plus unexplained variation is the total variance. The total variance is summation of y minus y bar the whole square is total variation. Explained variance is summation of y cap minus y bar the whole square is explained variance. Unexplained is y minus y cap the whole square is unexplained. The total variance is explained plus unexplained is a total variance. Okay. So this is R square is the most important thing in regression. So here, so this is the way we'll get the result in Python. So if you look into here, so the first and foremost thing in the regression result, is R square. So the R square value is 0.5808. So which means 58.08%. The variation in the house price is because of square feet. When we are changing 1 unit of the square feet, 58.08% variation in the house price will affect. So square feet affect the house price of around 58% square feet is affecting the house price. Okay, that is the way we can infer this result. The second, we need to frame the equation. We need to frame the model, machine learning model. The regressive model we need to frame. So this is the regression model. House price equal to 98.248 plus 0.109 into square feet. Okay, this is the regression model. Okay, house price equal to 98.248 plus 0.109 into square feet. This is the equation. So with the help of this value, with the help of this coefficient, here the house price is a dependent variable. Square feet is an independent variable. 98.24 is a constant. 0.109 is a coefficient. Okay. So with the help of this equation only we can frame the output. So this is a regressive model. The third important thing in the regression result is the corresponding p-value. The square feet, the corresponding p-value is 0.01. First, we need to look into the R square. Second, we need to frame the equation. Third, the corresponding p-value, we need to look into that. Here, the p-value is 0.01. Okay, here the p-value is 0.01, which is less than 0.05, which is less than 0.05. So we can say that the square feet is significantly affecting the house price. Okay, the house price is significantly affecting the house price. Okay, the square feet is significantly affecting the house price. Because of square feet, there is significant impact on the house price. Okay, because of square feet, there is significant impact on the house price. So this is an equation we need to frame. First, we need to look into the R square. Second, we need to frame the equation. Third, the corresponding p-value, we need to look into that. These are all the three things we need to be look into that. So how to infer this equation? How to interpret this equation? Here house price is 98.248. 98.248 is a house, the constant. Okay, 98.248 is a constant. Okay, what is the meaning of this value? So no one can construct the house in a 0 square feet, right? So if you want to buy a flat in the apartment, okay, if you want to buy a flat in the apartment, minimum we need to pay some amount, right? No one can construct the 0 square feet. Okay, so that is a constant 98.24. If you multiply it by 1000, we'll get 98,248. 1 minute. So here, if you look into that, 98.248 is a constant. So if you multiply by 1000, why we are multiplying by 1000? Because, so here, the value we are multiplying by 1000 because the house price is mentioned in $1,000. The house price is mentioned in $1,000. Okay. So the house price is mentioned in $1,000. So that's why. Okay, if you are if you look into this, the house price is mentioned in $1,000. Okay, that's why we are multiplying by 1000. So here, if you are multiplying by 1000, we are getting. So if you want to buy a flat, minimum we need to get $98,248. $98,248 is the portion of house price is not explained by square feet. Okay. So minimum, if you want to buy a flat in the apartment, minimum we need to pay this much amount. If you want to buy a flat in the apartment, minimum we need to pay $98,248. We need to pay this much amount. Okay, that is the meaning of this value. What is the meaning of this one, 0.109? So again, if you multiply by 1000, the coefficient, we are getting $109.77, which means on an average, for every additional square feet, if you are increasing every additional 1 square feet, we need to pay extra $109 extra. We need to pay that for every additional 1 square feet in the flat. If you are increasing every additional 1 square feet, we need to pay $109 extra amount we need to pay. So that is the meaning of this value. So this is constant, this is coefficient. Okay. So we need to justify this result. Then also, if you look into this, the confidence, the lower and the upper confidence value with respect to the square feet is our independent variable. Then the lower 95% is 0.033. Upper 95 is 0.185. So the lower and upper value. So in that case, here, what is the meaning of this lower 0.033, upper 0.185? What is the meaning of this value? If you multiply by 1000, so we can get $33.7 and 185, which means, so if you are increasing every additional 1 square feet, minimum we need to pay $33.7 minimum we need to pay extra amount. If you want to buy a flat, okay, every additional 1 square feet, minimum we need to pay $33.7 minimum we need to pay. Maximum it will go up to $185.8. Minimum $33 minimum we need to pay for every additional square feet, because there are different reasons are there. Some flat is a north facing flat, south facing flat, or east facing, west facing, or corner plot, or so there are different reasons are there. So depends on that. For every additional 1 square feet, minimum $33.7 is the minimum amount for every additional 1 square feet. Maximum it will go up to $185.8. Okay, minimum $33. Maximum will go up to $185. Okay, so that is the inference we can make. Okay, that is the way we can make the inference. Okay, so this is a regression. So regression is used to find the causal effect relationship. When we are changing one variable, how much impact is there on the another variable? That is explained in the linear regression. This is called linear regression. Also, this algorithm, the linear regression, is helpful for prediction also. How? With the help of this equation, which we found, right? With the help of this equation, we can make the prediction also. With the help of this data, we framed this equation. Now, we need to predict the price for a house with 2000 square feet. What is the predicted price for a 2000 square feet? So how much is the price for 2000 square feet? If you substitute 2000 here, what is the house price? If you substitute 2000 here, we are getting 317.85. If you multiply by 1000, we are getting $3,17,850. The predicted price for a house with 2000 square feet is the predicted price for a house with 2000 square feet is $3,17,850 is the predicted price for the house. Okay. So with the help of linear regression, we can do the prediction also. Okay. So this is a simple regression. So simple regression. So far we discussed the simple regression, which means one dependent variable and one independent variable. That is, the square feet is the independent variable. House price is a dependent variable. So based on the house price, we can do the prediction of, based on the square feet, we predicted the house price we predicted. Okay, based on the house price, we predicted the house price we predicted. Based on the square feet, we predicted the house price. Okay, we predicted the house price we just predicted. Okay, based on the house price, we predicted the, based on the square feet, we predicted the house price we just predicted. Okay, we predicted the house price we just predicted. Okay. Now we need to go for multiple regression. So multiple regression means one dependent variable, more than one independent variable is a multiple regression. One dependent, more than one independent variable is a multiple regression. Here, the equation also gets expanded. Y equal to beta naught plus beta 1 x1 plus beta 2 x2 up to beta n xn. This is the equation. Y equal to beta naught plus beta 1 x1 plus beta 2 x2 up to beta n xn. Here, x1, x2, x3 are the independent variable. Beta 1, beta 2, beta 3 are the respective independent variable coefficient. Beta naught is a constant. Y is a dependent variable. Okay. Y is a dependent variable. Beta naught is a constant. Beta 1, beta 2, beta 3 are the respective independent variable coefficient. X1, X2, X3 are the independent variable. This is multiple regression. So here, if you look into that, one dependent variable, more than one independent variable is a multiple regression. One dependent. Previously, we discussed only with respect to price and square feet. Now we have one dependent variable, more than one independent variable is a multiple regression. We go for multiple regression. Okay. So this is simple and multiple regression. So let me show you the same thing in Python also. This is the Python IDE, the IDE name called Spider. There are 8 IDEs are there, like Jupyter Notebook, Jupyter Lab, or Qt Console, Spider, like that. Spider is one of the IDE in the Python. IDE means Integrated Development Environment. Every programming software there is a IDE is there. For example, if you go to .NET, the IDE for .NET is Visual Studio. IDE for Java is NetBeans, Eclipse are the IDE. Likewise, if you go for Python, Spider is one of the IDE. Okay, Spider is one of the IDE. Okay. Now, whenever we go for Python, whenever you go for the algorithm, first and foremost thing is we need to import the file. Through the data only we can do the analysis, right? If you want to import the file, there is a package name called pandas. Import pandas as PD. First we need to import the package. Here the package or library name called pandas. Okay, pandas is a package which is mainly used for loading the data set. When you want to load any Excel file, we need to go for pandas package. So import pandas as PD. Pandas is a package which is mainly used to load the Excel file. Then next I am imported the another package name called stats model. Stats model is another package which is a statistical model. That is, when you want to do the linear regressions and all, we need to import the stats model package. We need to import. Okay. Then next thing, we need to load the data set. If you want to load the data set, let me load this file. May verify is this correct file or not. Yes, so this is a file I'm going to load. Price and square feet. Just copy this file and data set equal to p dot read underscore excel of file name. Sheet name is 0. Then data set dot head function. Head is used to print the first 5 records. Okay. Now I'm going to perform the simple regression first. Okay. Simple means what? One dependent and one independent variable. That is simple regression. So here the dependent variable is price and the independent variable is square feet. Okay, here y equal to data set of price. Okay. Price is a dependent variable and the independent variable is square feet. Here the dependent variable is price and the independent variable is square feet. Okay, price is a dependent variable, square feet is an independent variable. Along with the independent variable, I just added the constant. So let me go for simple regression. Simple equal to sm dot OLS. OLS of y comma x1. And result equal to simple dot fit function. Then result dot summary. So here the dependent variable is price. Independent variable is square feet. Along with the independent variable, I added the constant. So here simple equal to sm dot OLS, ordinary least square. So here dependent variable is price, independent variable is square feet. Then result equal to simple dot fit function. Then result dot summary. Okay, here the R square value I'm getting the R square is 0.93. Okay, which means 0.493, which means 49 percentage, 49.3 percentage, the square feet is affecting the house price. Then with the help of this equation, by using this value, we can frame the equation. With this, we can able to predict this. So this is a simple regression. So what I did was, so I just imported the pandas package. Pandas package is a package which is used to load the Excel file. Okay, then import statsmodel.api as SM. Statsmodel is a package which is used for linear regression. Then I just loaded the data set. Data set equal to pd dot. PD means the pandas. Just I created the instance for this object. Okay, pd dot read underscore Excel. So when you load the Excel file, we use pd dot read underscore Excel of file name linear regression dot XLSX, comma sheet name equal to 0, which means first sheet. If you load the first sheet, we use sheet name is 0. Then dataset dot head. Then it printed the first 5 record. We are not going to analyze only these 5 records. We are going to analyze the entire data set. See, if you go to this variable explorer, whatever variable we created, all the variables we can see that. Here, there is a variable name called data set. Here you can see that price, square feet, bedroom, bathroom, and floor. All the variables are there. We can see that. Okay, the entire data set only we are going to analyze. So y equal to data set of price. Price is a dependent variable. And the independent variable is square feet. So along with the independent variable, I just added the constant here. Sum dot add underscore constant of x. Then we go for simple equal to sum dot OLS. OLS means ordinary least square of y comma x1. Y comma x1. Y is a dependent variable. X is an independent variable. So here simple equal to sum dot OLS. Then we can fitment the model. Then we can summarize the result. Result dot summary. Here the R square value is 0.493. That is 49.3 percentage. Independent variable is affecting the dependent variable. Then we can frame the equation constant and the square feet. Okay, constant and the square feet. Okay, we can frame the equation. Then the corresponding square feet is, the p-value is less than 0.05. Okay, the corresponding p-value is less than 0.05. Okay, so we can say that because of square feet, there is significantly impact on the house price. Okay. So this is simple regression. When we go for multiple regression, what is multiple regression? Multiple regression means one dependent variable, more than one independent variable is a multiple regression, right? So now here I'm going to define price is a dependent variable. Price is a dependent variable. and the independent variables are remaining variables are independent variable, that is square feet, bedroom, bathroom, floor. Remaining variables are independent variable. Square feet is a dependent variable. Bedroom, bathroom, floors. Here the dependent variable is price and the independent variable is square feet, bedroom, bathroom, and the floor. So along with independent variable, can add the constant of x. When we go for multiple regression, Sm dot OLS of y comma x1. Okay. Then result equal to multiple dot fit function. Result dot summary. So now we get the multiple regression. See, here the dependent variable is price and the independent variable is square feet, bedroom, bathroom, and floors, or the multiple independent variable. Along with I added a constant. Then multiple equal to Sm dot OLS is the regression function. Dependent variable is price. Then independent variable. Then we can fitment the result. Then summarize that. Now we are getting the R square is 0.507, which means 50.7 percentage the independent variable is affecting the dependent variable. 50.7 percentage the independent variable is affecting the dependent variable. Now if you look into this, so the square feet and the bedroom, bathroom, and the floor. So out of these four independent variable, the floor independent variable, the p-value or significance value is greater than 0.05. If the significance value is greater than 0.05, so then the particular variable is not significant. So here floor is not significant independent variable. Only square feet, bedroom, bathroom. These three variables are significantly important. Square feet, bedroom, bathroom are the significantly important variable, where floor is not significantly important. Okay. So floor is not significantly important. Only these three variables are significantly important, and the R square 0.507, 50.7 percentage, 50.7 percentage, the independent variable is affecting the dependent variable. Okay. So this is multiple regression. One dependent, more than one independent is a multiple regression. Okay. So this is the way we can infer the result. So first we discussed the simple regression. Simple regression means one dependent and one independent variable. Multiple means one dependent, more than one independent is multiple regression. First we need to look into the R square, then we need to frame the equation, then we need to look into the corresponding independent variable, the p-value or significance value. Okay, this is linear regression. There is another concept called logistic regression is there. So logistic regression. So far we discussed the linear regression. So linear regression is helpful for predicting the outcomes. There is another machine learning algorithm called logistic regression. So logistic regression is a classification technique. Okay. So when we go for linear regression, as I already said, linear regression is used when both dependent and independent variable, when both the variables are continuous, then only we go for linear regression. When we go for logistic regression, the dependent variable is binary categorical. Okay, the dependent variable is binary categorical and independent variable is categorical and continuous. So in the logistic regression, the dependent variable is binary categorical. What is binary categorical? Binary categorical means yes or no, pass or fail, accept or reject. Only two outcomes, 0 or 1. Okay, so in the logistic regression, the dependent variable is binary categorical and the independent variable is categorical and continuous. Then only we go for logistic regression algorithm. Okay, so why we are not using linear regression? Because linear regression is used only when your dependent variable, that is your output variable and input variables are continuous one. When both the variables are continuous, then only we go for linear regression. Okay, otherwise we can't go for linear regression. So here in the logistic regression, we are using the logit is a function. So this is working completely because of logical function. You may learn in the childhood, in your childhood, you may learn the logical gates, AND gate, OR gate, XOR gate, NOT gate. These are all the logical gates. Okay, all these gates, outcomes we are getting is 0 and 1. Okay, 0 and 1 is a logical output. That is a logistic regression. Logit is a function name. So logit is a function name. Here we are using logit is a function name. So the first step is we need to frame the linear function. P equal to beta naught plus beta 1 x1 plus beta 2 x2 up to beta n xn. Okay, this is a linear function. Then we need to go for logistic regression. First, we need to go for linear function. Then we go for logistic. So here, this is a standard equation for logistic regression. So standard equation for logistic regression, that is P equal to 1 divided by 1 plus inverse exponential of linear function. Okay. So when we go for logistic regression, so when we go for logistic regression, 1 divided by 1 plus inverse exponential of the linear function. This is a logistic regression. Okay. Here x1, x2, x3 are the independent variable. Beta 1, beta 2, beta 3 are the independent variable coefficient. Beta naught is a constant. Okay. Beta naught is a constant. This is the equation P equal to 1 divided by 1 plus inverse exponential of linear function. Okay, P is the probability of getting the outcome. Okay. So next, if you find the odds ratio, odds equal to P by 1 minus P. P is the probability of success event divided by 1 minus P, probability of failure event. Probability of success event by probability of failure event is the odds ratio. Okay, if you inverse this P, you will get this value. So odds equal to exponential of the linear function. If you take log on both sides, log of odds equal to the logit. We'll get the logit. Okay. Now we'll look into this example. In this logistic regression, so we get the S-shaped curve. Whereas when we go for linear regression, we'll get to the straight upward curve. When we go for logistic regression, we'll get to the S-shaped curve because exponential is there in the standard equation. Because exponential is there. That's why if the exponential is there, that's why we'll get to the S-shaped curve. We'll get to the S-shaped curve. Now we'll look into one example. In this example, the dependent variable is whether the bank is going to sanction the loan or not. The output variable is yes or no, whether the bank is going to sanction the loan or not. The dependent variable is yes or no. And the independent variables are demographic information and information about the bank relationship. The independent variables are education profession, education graduation, securities, causal deposit, online, credit card. These are all the independent variable. The dependent variable is bank loan. Bank loan is a dependent variable. And these are all the independent variable. Now, when we go for regression, the first we need to look into the single predictor model. Single predictor model means one dependent variable and one independent variable. Okay, one dependent and one independent variable. So that is income is an independent variable, loan is a dependent variable. So we can write the equation is 1 divided by 1 plus inverse exponential of the linear function. 1 divided by 1 plus inverse exponential of linear function. Here beta naught is minus 6.35. Beta 1 is 0.03. With respect to these value, if you substitute here, we get the single predictor model. 1 divided by 1 plus inverse exponential of the linear equation. This is single predictor. When we go for multiple predictor, this is a single predictor. With respect to this equation, we can get this result. We'll get this outcome. So here 0.5 is the cutoff value. So if the person is getting more than here, if you draw the line like this, so the income is 160 here. If we are drawing the p value is 0.5. If you draw this, it is 160. So if that is the case, if the person who is getting more than $160,000 income, then only the probability of getting the loan is high. If the person who is getting more than $160,000, then only the probability of getting the loan also high. Okay, that is a single predictor model. That is one dependent and one independent variable. Okay, here 0.5 is a cutoff value. So previously we discussed single predictor model. Now we can go for multiple predictor. So previously we discussed simple and multiple regression. Now we have single predictor model and multiple predictor model. Single predictor means one dependent and one independent. When we go for multiple predictor, one dependent variable and more than one independent variable. The independent variable is more than one independent variable. Here we have age, experience, income, family, CC average, mortgage, security account, CD account, online, credit card, education, graduation, profession. These are all the independent variable. So one dependent variable, more than one independent variables are the multiple predictor model. Here in this, the p-value, whichever independent variable, the p-value is greater than 0.05, that variable is not significant. Whichever is less than 0.05, that variable is significant. Out of these 12 variables, except age and experience, remaining all the variables are less than 0.05, which means remaining all the variables are significant. Okay. So remaining except age and experience, these two variable only, the significance value is greater than 0.05. Other than that, all the variables are less than 0.05. And in that, the income, CD account, education, graduation, education, profession, these variables are having the p-value is 0, which is the most significant variable. These four variables are the most significant variable. Income, CD account, education, graduation, education, profession. So these variables are most significant variable. So these variables are most significant variable, we can say that. These are all the most significant variable. So with respect to this coefficient, we can frame the equation minus 13.2 minus 0.04 into age plus 0.057 into experience. So with respect to this coefficient, we can frame the equation. Okay. With the help of this equation, we can get to know if we are getting the probability value is greater than 0.5, then the person will get the loan. Otherwise, they won't get the loan. Okay. So based on that, we can classify that whether they are eligible to get the loan or not. We can get to know based on the p-value. So this is logistic regression. So when we go for logistic regression, most importantly, you need to remember that the dependent variable is binary categorical and the independent variable is categorical and continuous. Then only we go for the logistic regression, that is a variable selection. Then here p-value is a deciding factor. How in linear regression? What is a deciding factor in linear regression? In the linear regression, R square is the deciding factor, right? Likewise, in the logistic regression, p-value is a deciding factor. Okay. So to summarize that, both linear and logistic regression, both are used to find the causal effect relationship. So when we go for linear regression, both dependent and independent variable, when both are continuous, we go for linear. When we go for logistic regression, the dependent variable is binary categorical and independent variable is categorical and continuous. We go for logistic regression. Okay. So that is linear and logistic regression. So let me show you the same thing in Python also. So first I'm importing the pandas package. Then import as model.api as sm. Here data set 1 equal to underscore excel of file name. So we can go for logistic regression. Yes, 1 minute. I'll explain this. Here, so here we can import the pandas package. Here, import pandas as PD. Then import statsmodel.api as SM. Then we loaded a logistic regression file. Then we printed the head function. Here, the dependent variable is admission. Admit is a dependent variable. Whether the student is going to get the admission into the college or not for appearing the PG course. Admission is a dependent variable. And the independent variables are GRE, GPA, rank. These are all the independent variables. Here the dependent variable is admission. Independent variable is GRE, GPA and rank of the college or the independent variables. Okay. So now the dependent variable is admission. Independent variable is GRE, GPA and the rank. Okay. Along with we are adding the constant. Then we go for logistic equal to sum dot logit of y comma x1. Okay. Result equal to logistic dot fit function. Okay. Result dot summary. Result dot summary. Here import pandas as PD. Then import statsmodel.api as SM. Then we loaded the file. Then we used the head function. Admission is a dependent variable. Remaining all are independent variable. Along with I added the constant. We used the logit function. So logit is a function name in the for logistic regression in Python. Dependent and independent variable. Then we can fitment the value. Then we can summarize the result. Now here, so here we are getting the p-value. Okay, here we are getting the p-value is here. So all these independent variable, GRE, GPA, rank, all these independent variable, the p-value is less than 0.05. See then, all the independent variable, the p-value is less than 0.05. GRE, GPA, rank. In this, rank is a variable which is closer to 0. Okay, rank is a variable which is closer to 0. Okay, rank is a variable which is closer to 0. So rank is a variable we can say which is very closer to 0. Okay, rank is a variable which is closer to 0. So which means based on the rank of the college, based on the rank of the college only we can get to know. Okay, based on the rank of the college we can get to know. So which variable is significantly important? Okay, rank is the most significant variable. Okay, compared to other variable, rank is the most significant. Okay, so based on this value, coefficient value, we can frame the equation. With the help of this equation, we can decide whether the applicant will get the admission or not. We can take the decision. So this is logistic regression. Okay. So let me quickly summarize that. What is linear and logistic regression? So you can tell me the difference. What is the difference between these two algorithms? We discussed the linear regression, right? Linear regression. Also, we discussed the logistic regression. What is the difference between these two algorithms? What is the first difference? When we go for linear regression, dependent variable and independent variable, when both the variables are continuous. When both are continuous variable, we go for linear regression. Whereas in the logistic regression, the dependent variable is binary categorical and the independent variable is categorical and continuous. Okay. Then is there any other difference? In the linear regression, the deciding factor is R square, right? Which is ranges between 0 to 1. And in the logistic regression, P value is a deciding factor, which is 0 to 1. And in the linear regression, we'll get the straight upward curve. Whereas in the logistic regression, we'll get the S-shaped curve. Is there any other difference? In the linear regression, the standard equation is beta naught plus beta 1 x1 up to beta n xn. Whereas in the logistic regression, p equal to 1 divided by 1 plus inverse exponential of beta naught plus beta 1 x1 up to beta n xn. This is the equation. Then what else is the difference? When we go for linear regression is a predictive algorithm. So this is a predictive algorithm. So based on the square feet, we predicted the house price, right? This is a predictive. Whereas logistic regression is a classification algorithm. Okay, linear regression is a predictive algorithm. Logistic regression is a classification algorithm. Okay. So this is a difference between linear and logistic regression. So in the linear regression, both linear as well as logistic regression, both are come under supervised learning. When we go for linear regression, both dependent and independent variables were continuous, then only we go for linear regression. Whereas in the logistic regression, the dependent variable is binary categorical and the independent variable is categorical and continuous. In the linear regression, R square is a deciding factor. The R square value is ranges between 0 to 1 and we are getting the upward curve. When we go for logistic regression, here the p-value is a deciding factor. P-value is ranges between 0 to 1 and we are getting the S-shaped curve we are getting. And here we are getting the equation is beta naught plus beta 1 x1 plus beta 2 x2 up to beta n xn. Whereas when we go for logistic regression, 1 divided by 1 plus inverse exponential of linear equation. The linear regression is a predictive algorithm. Logistic regression is a classification algorithm. Okay. So this is linear and logistic regression. Okay, this is linear and logistic regression. Okay. Next. So far we discussed what are all the things we discussed in this session. So in this webinar, what are all the concepts we discussed? Can anyone summarize? So in this workshops, so this workshops is on machine learning. So what are all the things we discussed in this session? First, we discussed machine learning. Machine learning. Then modules in machine learning. So then we also discussed the application of machine learning. Then how we must use in machine learning. Then clear path. So these are all the different concepts we discussed. Then we discussed the supervised learning algorithm. And then we discussed linear regression. Types of linear regression, simple and multiple. Then Python is we executed. Then also we discussed types of these are all the different concepts we learn. Also, we discussed the difference between linear and logistic regressions, right? So these are all the different concepts we discussed in detail with real-time example, right? Uh, about machine learning, then also we discussed the different algorithms, supervised and the supervised linear and logistic. Then also we discussed the difference among this algorithm. Okay. So there are so many algorithms are there, which is more interesting to implement in the real-time business. So we will discuss more in the upcoming workshops or webinar. Okay. So that is all about this session. Hope you acquired knowledge on machine learning, the applications of machine learning by using Python. Okay. So that is all about this. And so before going to this question answer session, so let me brief about what is Brainswig, what we are, what are all the things we are doing, and so far what we did. So let me brief in one small video clip. So that is all about this session. So I request you to ask the questions, whatever questions you have. So you can just ask your question.
Yes, students, you can ask questions.
Meanwhile, I just sent you the text, the feedback in the chat. So hope everyone get the feedback.
Sir, your voice is breaking, sir. Yes, sir.
Yes,
Yes, sir.
ma'am.
Now it's
Hello.
clear.
Yes, ma'am.
Yes,
Is it
sir. Now it's
audible?
clear.
Okay. Yeah. So in the chat, I sent the feedback link where they can submit the feedback link in that. So your individual feedback is very much important for us. So there are two links. One is from Brunswick, another is from your college also. So there are two links are there. So kindly submit in both the links. You can submit the feedback. So any doubts, you can go ahead.
Students, you can ask questions now. Sir, thank you, sir. Thank you for your insightful presentation. We are grateful for the time and effort you took to share about supervised and unsupervised learning, association rules, reinforcement learning, and about its relation to data science. Application of machine learning in manufacturing sector, the tools used for machine learning and its algorithms, and also the skill set that are required to become a data scientist. Thank you, sir.
Yes. Thank you, ma'am. Thank you for the
Thank you, sir.
opportunity, ma'am. Yes, thank you. Yes, shall we
One
close
second,
the
sir.
session, ma'am? Huh.
Sir, in chat box we have some questions, sir. Can I read it, sir?
Huh.
How does
Yes, ma'am.
machine learning differ from deep learning?
Right. So when we go for machine learning is based on the past data, that is the numerical values, whatever we have the numerical values. With the help of that, if you are analyzing, that is machine learning. Under machine learning, these are all the modules, that is supervised, unsupervised reinforcement. When we go for deep learning means the human being intervention is there, which means the NLP, natural language processing, text analysis, and also the recognition, speech recognitions. These are all the concepts which is come under deep learning. Deep learning means where the NLP is there, where when we want to analyze the reviews of the Facebook or Twitter or Amazon reviews and all, if you analyze, that is a deep learning where when we go for machine learning in that machine learning, we have we have structured data only we can analyze, whereas when we go for deep learning, both structured as well as unstructured data we can able to analyze that. Okay. Mm,
Sir,
that
next question,
case,
sir.
let me. Yes, ma'am.
Can I ask, sir, next question?
Yes, ma'am.
What is
Go
the
ahead.
difference between the training set and the test set? Why do we split on the dependent variable only?
Right. Mm, yeah. So the training data set and the test data set is mainly so why we are going for training and test mean whenever there is a classification is there, whenever we are going to classify the records, we go for training and test data set. Training means with the help of past data, if you are analyzing, we go for test data, training data set. Let me give one example. So first of all, I just brief about this deep learning and machine learning. So coming to this deep learning, so deep learning, we can go for the huge amount of data we can able to analyze. Whereas when it comes to machine learning, we can work with the huge amount of structured data only. But when we go for deep learning, both the structured and the unstructured data we can analyze. And when we go for machine learning, we have the number of algorithms are there. But when we go for deep learning, very few algorithms, that is NLP and image recognition, Viola Jones algorithms and all. And when we go for machine learning can perform the large data set. When we have the more and more data sets increase, so the performance wise will affect. Whereas when we go for deep learning, we can able to analyze the large data set also, we can analyze that. Okay, and the feature extraction. When we go for machine learning, we can extract the pattern and meaningful insight from the data. While when we go for deep learning, we can just absorb the similarity of the data only. We can absorb that. This is a difference between the machine learning and deep learning. Okay, machine learning can perform the only structured data, whereas deep learning can perform both structured and unstructured. Under machine learning, we have set of algorithm. Under deep learning, we have set of algorithms. Okay, that's the difference. Then the second one is what is training and test data set. So training data set means, let me give one more example. So training data set means the past data set. With the help of past data set, we can apply the machine learning algorithm. Through this, with the help of machine learning algorithm, we can build the machine learning model. With the help of machine learning model, we can do the test data set prediction or classification. In the test data set, most of the, if whenever the prediction is there, output variable won't be there. So we need to predict in the test data set. If you go for a classification technique based on the training data set, how much similarity or similar characteristics are there in the test data set. So that is a training and test data set.
Yes, sir. One more question, sir. How can we handle an imbalanced data set?
So when the data set is not balanced, we need to collect the more sampling. We need to go for right sampling methods. So if we are not having the right sampling, we need to increase more sample, or we can go for the proportionate sampling method. Through sampling method, we can handle the imbalanced data.
Okay, sir. Thank you, sir. Sir, thank you for your knowledgeable session, sir.
Yes. Yes. Thank you, ma'am. Thank you all, and kindly submit your valuable feedback in both of the links. Yeah.
Thank you,
Thank
sir.
you. Thank you, ma'am. Yes. Thank you.
Students, kindly ensure that you fill both the feedbacks. Okay? Only after filling up the feedback you can leave. I would also like to extend my thanks to all the participants for their cooperation. Thank you all.